x is going to be what? 6x squared, and fy of xy is going to be what?
4y cubed.
4y cubed. So this is going to be 0 only when what? At what point?
0, 0.
Only at 0, 0. Okay, so that's nice. There's our critical value. It's defined everywhere. The fun part is we have to do what?
Quarter.
Sketch the boundary.
Yeah.
Sketch the boundary in some way. So what are we really looking at? We're looking at, we have our domain on the xy is really just this.
So you can draw a cylinder.
It's like a cylinder, right? So essentially the question is, what's the path along that cylinder? What's the path along that cylinder? This is different. Now this is different because we've looked at paths, we've looked at boundaries that are linear. We've looked at like boxes or triangles. How are we going to attack? And that is the path of the boundary. Now in terms of sketching that, do we really need to sketch it? No, we need to find what the maximum and minimum values of that are. That's a single variable equation, so what can we do?
Take the derivative.
Yeah, we take the derivative. F prime of x is going to be 6x squared plus 2 times 1 minus x squared. It is recording to the first times what?
Minus times negative.
Negative 2x, right? So we end up with 6x squared minus 4x times 1 minus x squared. So we end up with 6x squared minus 4x plus 4x cubed, to put this in order because we're compulsively ordering things. 4x cubed plus 6x squared minus 4x. Factor out a what? Let's factor out a 2x. So end up with 2x squared plus 3x minus. When you see a quadratic like that, you hope it's what? Well, is it what?
Factorable.
Is it nicely factorable? We don't need to record all this algebra. We already know 0. What's f of 0 is?
1.
F of 0 is 1. F of 1/2 is going to be 1/4 plus 1/2, 1/4, 3/4, 9 over 16. Is that correct? Is that correct?
Yep.
Thank you. And then f of negative 2 is going to be negative 16, 4, 5 plus 25, right? Is that correct? Negative 2 into there, right? 9. It's 1 minus 4, so yeah, so it's going to be 9. So it's going to be negative what? 7. So there's our minimum.
The middle one is 13.
And this one's 13 over 16. And where's our maximum? Oh, 13, 16. I was thinking of it flipped. So this is our max. Good.
What do you do with the critical point? What's the point?
Ah, the critical point. Let's go back and test the critical point. Let's take 0, 0 and plug it into here. What do you get?
0.
0. So therefore, that's just another place. So effectively, is it an absolute min or an absolute max? No. Let me just check something here. Go ahead. And we end up with e to the negative x squared plus y squared times. Oh wait, we'll factor out negative 2x as well, like that. And you end up with x squared plus 2y squared minus 1, right? Equals 0. What's the only way to make that equal to 0? X equals 0, but then you also know x squared plus 2y squared has got to equal what? 1. Nice. X squared plus y squared is 1. So that's what we get from here. So at this point, what would be a good thing to do? Before we do anything else on this one, what could we do?
Look at the...
Yeah, let's look at this one, yeah. If we look at this one, what can we factor out? Negative 2y e to the negative x squared plus y squared times what? X squared plus 2y squared minus 2, right? So this only happens when what? That could be y equals 0 right there, but then this one right here is x squared plus 2y squared is equal to what? To 2. Okay, what do you notice at this point? There's a key piece that you can notice here. Is it possible for these two things to be true at the same time?
No.
No. Unfrowny face. But that's actually kind of cool because if it can't be true, what can you look at? Yeah. So the only point you have potentially is 0, 0. We absolutely can.
Would you like me to read it to you?